Have you ever gazed at the beautiful night sky and dreamed of an interstellar journey? Well, you're not the only one. When Apollo 11 landed, the first two humans on the moon, in 1969, the world was full of hope of dreaming of a summer vacation to Mars, and beyond soon. Yet here we are, after nearly 50 years later, still stuck on Earth. Well, Voyager 1 is now nearing the edge of our solar system. So, why is it so hard to get beyond the solar system? The gravity. According to Newton's first law, force-free objects always move in a straight line. Kepler's law says that the pulling force, centripetal force, and the pushing force, centrifugal force, cancel out each other and cause objects to float in a circular motion. It needs tremendous energy to break this law. If you are lucky to escape gravity, watch out for asteroids before you run out of fuel. Most of all, space is far too big for modern technology to explore. The universe is 46 billion light-years away, and since the Big Bang, it is still expanding at 68 kilometers per megaparsecond. It's not kilometers, feet, or miles. It's in light-years. It can be only measured by the speed of light, in other words, by the unit of time. So in space, distance and time are all mashed up into one. In his Special Relativity theory, Einstein said that in space, there's no distinction between space and time. In physics, space-time mashes the three dimensions of space and the one dimension of time into a single four-dimensional continuum. Unlike in his general relativity, where the speed of the object is relative to the observer's frame of inertia, where the speed of the moving object is dependent to the speed of the observer, Einstein insisted that the speed of light within the vacuum is the same, totally independent, no matter the traveling speed of an observer. When the light is traveling at 300 million meters per second, an observer's speed becomes irrelevant, thus independent. The space-time theory is exciting in quantum physics because it can create shortcuts for long journeys across the universe through a theoretical passage called a wormhole, or Einstein-Rosen bridges. These bridges connect two different points in space-time. Last year, 3 Americans have won the Nobel Prize in Physics for their works for LIGO Virgo, detector that discovered gravitational waves. Gravitational waves can warp the space-time further, possibly creating a wormhole. Theoretically, if you fold space in half and add the mass equivalent to Jupiter, it can create a warp in space-time to create a shortcut to the other side of the universe. So now you got it, space-time. Maybe the day we can go beyond the solar system isn't as far as we thought. See you on Mars!